Okay, we are going to go through Unit 1, Day 7 in your notes, so if you could pull those out. We can start by going through the warm-up. So what I'll have the substitute do right now is I'll have the substitute pause and give you guys about 4 minutes to complete both question 1 and question 2 before we get going with today's notes. Okay, hopefully after that pause, you guys completed 1 and 2. I'm going to go through both of those right now for you. All right, so I've already got these filled out for you. I've got question 1 filled out. We're quickly going to go through this. This was something we talked about yesterday, so I'm not going to spend too much time on it. But this is defined as a line. How do I know it's a line? Because it's got 2 arrows going in both directions, just like that. I labeled it line, and then I got a choice kind of on how I wanted to write how I wanted to define it, I guess, to you guys. So I am going to call this RS. I could have just as easily called it SR, and it would have been correct. But I've got my arrows on top. I've got my line drawn on top. And again, if I were to speak this, I would say line RS. You always say what the symbol is on top first, and then whatever's under it, that's how you'll read it. So I would call that line RS. And it's a line. It's got arrows. For the next one, I've got a ray. Now, how do I know it's a ray? We've got a starting point, and then it doesn't end going in one direction. So that's a ray. Remember, we got to be a little specific on how we write rays. This one has an arrow pointing to the right, which they all will have. You will never have an arrow pointing to the left. And then I have to be specific on the order that I put those. P, Q is correct. This was kind of an easy one because the arrow's already pointing to the right. There's often times that you'll have arrows pointing to the left, over here, like in your picture. You still have to, when you write it out, you have to write your arrow pointing to the right. I know P comes first because P is at the end point right there. So I'm going to put it under my end point. Q is closer to the arrow, so I'll put that next to the arrow. Last one. This is a line segment. How do I know it's a line segment? It's cut off on both sides. There's no arrows going anywhere. So those are end points. So I wrote line segment, and then over here I put UT. On this one I could have just as easily flipped those around as well and called it TU, but I did put a segment on top, not a line, a segment, because it's not a line because the line would have arrows on it. That one obviously doesn't have any arrows on it. So that's what you should have for that first question. If I'm going over to number 2 here, this is just a solving question. I've got negative 6w minus 7w. I combined those like terms first, and I put negative 13w. Then I copied the rest of the problem down. I added 27 to both sides. I divided by negative 13 on both sides, and I got w equals negative 5 for that one. All right, moving on to somewhat recent information. We did talk about this a little bit yesterday. Let's quickly just talk about what that picture is looking like. So if I have a plane, and I've got 2 lines, it looks like. I've got one going this way. That one looks like it's on the plane. All of the points are on the plane. They're inside the boundaries of that plane. Even though there isn't really boundaries, these are inside of those boundaries, so we know they're on the plane. Versus these 2 points, we've got R and T right there. Those 2 points are outside of the plane in the drawing. That means they're either above the plane or below the plane. Therefore, that means that this line must be going through the plane. It must be, because there's a point right here that it's on the plane, so it's touching the plane just at S and then going through all the way down to T. All right, so I guess there's a couple more things we can quickly talk about. Q is a point that's on the plane, and then P isn't a point at all. We just use that to help name the plane. So if I'm naming a line right here, actually, here's what I'll do. I'm gonna pause for a second, or I'll have the substitute pause for a second. I would like you to try this. We just got done naming stuff up top. Are you able to do this? So let's pause for like 2 minutes and give everybody a chance to try to write one of these. Okay, now that you've paused and you're coming back to me, we are going to name a line. You've got 2 options for lines. It can be that one or it can be that one. You could go pretty simple and just do the one that's on the plane. If I wanted to name a line, remember I'm naming it with 2 points only. So I could name it XY, for example. I know that S is on there, but I only need 2 points. I'm going to put a line on top of it, and that would be a perfectly fine name for that line. I could have also named it RT, for example. I could have named it with S in there if I wanted to, but RT works perfectly fine, and we've used 2 points So either of those would work. Let's name a plane. The easiest way to name that plane we've already talked about. I would call it plane P if I wanted to be quick about it. Otherwise, I would like you to try naming it with 3 points. And remember, those points have to be non-collinear points. So I can't just use X, Y, and S. I also will not use R and T. Those aren't even on the plane, so you can't name a plane using R and T. So I've got these 4 options, and they have to be non-collinear. So one example could be plane Q, X, Y. Those 3 points do not form a line, so that works. Naming array. Now, if you're looking at this picture, you don't necessarily even see array on here. I see 2 lines, and I see a plane. But all lines can be broken down into arrays. For example, if I'm just looking at, I'll pull out my highlighter really quick. If I'm just looking at from S to R, where that arrow is, that's technically array. It's just a portion of that line. Going back to my pen, if I were to write that out, I could say, well, we're starting at S, and we're going in the direction of R. Our starting point was S, going in that direction. So that would be a perfectly fine array. Going on to a line segment. A line segment has a starting point and an end point. I'm seeing a really easy one to write there. Even though this is a full line, I can say a part of that line would be from X to Y. I don't put my arrows on the end of it because I'm not talking about a line now. I'm talking about just the segment from X to Y. It's a portion of a line. All right, let's get into some ALEKS topics. This is what you guys will be working on today. So for this ALEKS topic, we've got a variety of things going on here, but I just want to focus one more time on the picture. It looks like this line is on the plane. It's like it's drawn on the plane. This line is going through the plane. We know it's going through the plane because this is off the plane. It's on the plane at M, so that must be where it's touching the plane and going through it. And then it's off again on N. It's on top, touching, and then on bottom. So it's definitely going through. Think of a pencil going through a piece of paper and then just kind of sticking there. It's going through the plane like that. All right, so another name for plane Z, we're going to go pretty quickly with this time. So plane Z, they've already used Z. So another name, I'm going to use 3 points. These are going to be non-collinear points. So I'll go plane, I guess it already had it written for me there. Plane H, J, and I'll pick P. Those 3 points aren't in a line, so they work. Next one, it says N blank and blank are distinct points that are collinear. Distinct, don't get too carried away with this. Distinct just means different points, 3 different points. So I need 3 points, one of them is already given to us, N, that are collinear. So what other points are on the line, collinear, with N? Where's N located? N's right there. So what other points do you see that are on that line? I'm seeing M and L all on the same line. Okay, so then we can go through, it looks like I've got 3 extra blanks here. Our distinct points are just different points that are coplanar. So what other points are on the same plane as H? Well, we can pick J, we can pick K, those are all on the same plane. We can pick P, P is on the plane. We could have also picked M, M is on the plane too. Suppose line JP is drawn onto the figure. Okay, this is where it gets a little crazy, so I'm going to actually erase quick. 1 second before we get too far in. This is typically the question that I have the most hands up for in class, by the way. Suppose line JP is drawn on the figure. So there's a line drawn from J, go back to my pencil, J to P. If I'm drawing a line from J to P, it's going to ask me what it's intersecting with. So JP, here's my line. I'm going to draw it as a line, which means I'm going to draw it longer, and I'm going to draw arrows on it. It's asking which line is it crossing, which line is it touching or intersecting. You really have 2 options. It could be crossing this line, as you can see, looks like it might be crossing there, or it might be crossing this line. Which one would you say? Well, the only proof that you're going to have is if two lines cross, they cross at a point. Do this line, the line that we just drew, does that line share a point with any other line? Well, in this case, it's pretty simple. It's sharing that point with this line HK, which J is involved in. So JP, this line, must intersect that line there. So I'll call it HK. Where are they trying to trick you? Okay, I'll tell you, this is where they're trying to trick you. They're trying to get you to say, well, these two lines here are crossing. I can see it on my screen, right? I can see it right there. They're not really crossing though, because like we said, after M, this one goes under the plane. It's two-dimensional on your paper, but it's three-dimensional in the real world where this is happening. Okay, so let's just quickly go through A. Suppose line GF is drawn on the figure. So G to F goes from here to here. And we said it's a line, so let's continue that line. It says GF, the line that we just drew, and blank are lines that intersect. Well, which line is it touching right now? Is it touching this line here? Kind of seems like it is. We know one thing is true though. We know that they're sharing this point F. It's going through F. And F was already a part of this line. So that must mean it's intersecting with this line since they're touching and sharing points. I'm going to call it DE. And I'll be done with it. I'm going to finish with one last piece here. I know that there's more on this paper, and I'd like you guys to try that one. But I'm going to explain one last piece, and this is important. Why is this line not touching this line? Because it's not. It's not. Think about it for a second. Here's why. If this line that we drew, the red line there, if this line is touching F, or it's sharing F, that means when F is below the plane, this line's going through it. Which means this line also has to be going through the plane. So you've got two lines, this one and this one, that are both going through the plane. This one's on top of the plane. So there's no way that this one, which is going through, and the one that's on top of the plane are touching. It's a little bit complicated. I'm going to let you guys try to figure that out. I would like you to finish this and then try this one, and when you're done, it would be really helpful if you could just turn to your partner and see if you got the same answers, or check each other's work. After that, you've got this one ALEKS topic to try to finish up. Actually, what we're going to do is we're going to save that ALEKS topic for tomorrow, and I have an assignment made for you online. It's going to be a few of these questions, sorry, the bell. Some ALEKS questions, and then some other questions that I have on there. You'll just go on to ALEKS, and it should pop right up for you. We'll save this topic for tomorrow, though. Let's do the homework first. Hopefully that makes sense for you. Thank you.